Good morning. Today's lesson will deal with a very important physical law, the law of conservation of angular momentum. If a system does not interact with its environment in any way, then certain mechanical properties of the system cannot change. They are sometimes called constants of the motion. These quantities are said to be conserved, and the conservation laws which result can be considered to be the most fundamental principles of mechanics. In mechanics, examples of conserved quantities are energy, momentum, and angular momentum. The conservation laws are exact for an isolated system. Objects executing motion around a point possesses a quantity called angular momentum. Is the momentum due to the rotation or revolution of matter? It is, in effect, a measure of the quantity of rotation in the matter, accounting for the mass, speed of rotation, and shape. It is important in physics because it is a conserved quantity. The angular momentum of a system remains constant unless acted on by an external torque. Angular momentum can be described as the rotational analog of linear momentum. Angular momentum, like linear momentum, involves elements of mass and displacement. Angular momentum, unlike linear momentum, also involves elements of position and shape. Where linear momentum is proportional to mass and linear velocity, angular momentum is proportional to moment of inertia and angular velocity. Unlike mass, which depends only on amount of matter, moment of inertia is also dependent on the position of the axis of rotation and the shape of the matter. Unlike linear velocity, which occurs in a straight line, angular velocity occurs about a center of rotation. The angular momentum of a system of particles, a rigid body, is the sum of the angular momenta of the individual particles. For a rigid body, the angular momentum can be expressed as the product of the body's moment of inertia, that's to say, a measure of an object's resistance to change in its rotation velocity, and its angular velocity, omega. Angular momentum is a vector quantity that represents the product of a body's rotational inertia and rotational velocity about a particular axis. It is defined as the cross product of its linear momentum, m times v, v being its tangential velocity, omega r, and its position relative to the point about which it is rotating, r. Angular momentum is conserved in a system where there is no net external torque, and its conservation helps explain many different phenomena. This is an important physical quantity because all experimental evidence indicates that angular momentum is rigorously conserved in our universe. It can be transferred, but it cannot be created or destroyed. When most people think of rotation, they think of a solid object like a wheel rotating in a circle around a fixed point. Examples of this type of rotation, called rigid rotation or rigid body rotation, include a spinning top, a seated child's swinging leg, and a helicopter spinning propeller. Rotation, however, is a much more general phenomenon and includes non-circular examples such as a comet in an elliptical orbit around the Sun, or a cyclone in which the core completes a circle more quickly than the outer parts. Conservation of angular momentum has been verified over and over again by experiments, and it's now believed to be one of the three most fundamental properties of physics, along with conservation of energy and momentum. In the following examples, we can see different sport situations in which the conservation of angular momentum is involved: long jump, artistic gymnastic, discus throw, and ballet. By keeping their arms and legs tucked close to their centers of mass, they are able to rotate faster. This is because, just like linear momentum, the momentum of rotation, the angular momentum, is also conserved. Angular momentum depends on the speed of rotation and the distribution of weight from the center of mass. Many thanks to Chiara, Virginia, Joela and Federica, the students who helped me with their nice sport performances.